Vision, images to training input. Organizing multiple images into image data, such as input tensors and label tensors, is a critical step in creating effective image recognition algorithms. Transforming raw images into a structured data format like tensors allows deep learning networks to efficiently learn from the dataset. Tensors are like special containers that can hold image data in an organized way. They also make it easier and faster for the computer to do complicated mathematics, which is essential for tasks like image filtering and recognition. This tool helps us organize images for efficient image recognition training. Let's explore it. Here we have 3 image classes, labels as 0, 1, and 2. For each image class, we can select 1 to 3 image samples. These images are just black and white pixels with 4 rows and 3 columns each. This is a super simple image system to make things easier. In real life, the images are much larger. The first image is pre-selected for all image classes. You can select and unselect other images to see how their image data arrays and tensors are constructed. So for now, I'll leave the settings as for image 1 for 0, image 1 and 2 for class 1, and image 1 and 2 for class 2. Here we see the image data for the selected image as a number of arrays. The numbers are colored based on the image classes. That is, image data for 0 images are displayed as green. The 1 images are displayed as yellow, and for 2 it is light pink. Since only 1 image is selected for the 0 class and the image size is 4 by 3, we should expect only 12 numbers to appear as green in the image data section. Since a white pixel is represented by 1 and a black pixel is represented by 0, we can start mapping the data from the top left of this image. We read 1, 0, 1, and here it is, 1, 0, 1. Then the next pixels are 0, 1, 0, and here it is, 0, 1, 0. Similarly, we can see the image data for the second image class as these yellow numbers, and so on. Next, we have the representation of image classes as label data. We use a special encoding to show the labels as below. We show 100 to represent class 0, 010 to represent class 1, and 001 to represent class 2. So we expect 5 data elements in this section because we selected 5 images. 1 class 0 image, 2 class 1 images, and 2 class 2 images. This coded label data is also color-coded for easy reading. Next, we have the image data as an input tensor, which we can also call train XS or training data X. In general, the data type of this tensor is a float, the rank is 4, and its shape is 5, 4, 3, 1. The first shape dimension indicates the number of image samples, which is 5. The second shape dimension indicates the number of rows in the image, which is 4. The third dimension shows the number of columns in the image, which is 3. The fourth and last dimension shows the pixel value, which is just a single number, as 1. Here we have the tensor values for this 5, 4, 3, 1 shaped tensor. Finally, we have the label tensor. This tensor is of data type integer with rank 2 and shape 5, 3. The first shape dimension indicates the number of image samples, which is 5. The second shape dimension shows how many numbers represent a label, which is 3, as discussed earlier. This covers how this tool helps us visualize and understand how multiple images can be represented as image data, label data, input tensors, and label tensors. Please feel free to play with this tool by selecting or deselecting different images and observing these images as data and tensors.